Welcome to B Spice. In this session, we'll continue with mastering alarms. In session 4, we'll talk about the most important aspect of alarm design, meaning the practical consideration for alarm design. So if you are a first time viewer, last three videos we had covered the mastering alarms, wherein the first session was on the intro part and the second session was related to principles of alarm system design, and the third session was about the alarm system design itself. Now we will see the practical consideration for alarm design. Okay, so agenda is like this: key principles and generation of alarms. So under generation of alarms, types of alarm, first up alarms, selection of alarm settings. So these are the topics, very short and sweet, yeah, but very important. Okay, let's see the key principles. As you know, friends, alarm actually system can achieve their objective of supporting operators if the correct type of alarms are selected and they are all configured appropriately, isn't it? I hope you agree with this statement. So alarm setting should be properly defined during plant design and commissioning and reviewed and optimized based on operational experience. Right. So every sensor should be located in a position where it will work reliably for a long period. That's an important point. Generate a good signal and of course to easy to maintain. So, where a high risk reduction is required for an alarm, a high integrity alarm system should be used. It is essential that operators are able to easily identify each alarm that they receive. So, these are some of the key principles we need to focus when we design an alarm. Okay, right. Now we go into the generation of alarms. Under generation of alarms, okay, we'll focus on the types of alarms. Okay, alarm system can achieve their objective of supporting operators if the correct types of alarm are selected and they are all configured appropriately. This is the first point I talked earlier, right? Yes. So again, I reiterate this. Okay. Now we go into the types of alarms. Okay, there are many alarms. Okay, maybe before that, just want to put forth some thoughts. See, alarm detection should provide early warning, right, friends? So that there is a problem requiring operator intervention. Okay, right. To achieve this, most appropriate alarm detection mechanism should be chosen for each parameter. So we are going to dive deep. What are all those methods for detecting alarm? So one is the absolute alarm. What is this absolute alarm? Absolute alarms are generated by comparison of an analog signal against a defined alarm setting or by a switch type sensor. Okay, friends, you got it? So, this absolute alarms are generated by comparison of an analog signal against a defined alarm setting or a switch type sensor. So this typically used to warn of a parameter approaching an absolute limit, such as trip or safety valve setting. Okay, so this is simple to engineer actually, but it tend to cause difficulty during abnormal operational situation. So we may need to take conditioning we may need conditioning to take the account of process operating state and which condition it happens. So we need to analyze that while setting the this type of absolute alarms. Now, bit pattern, this it's a digital, right? Is generated when a pattern of digital signal matches a predetermined pattern. Okay. Then calculated alarms. So this is generated in software based on logical combination of several signal. So that is the point. Okay. Yeah. Then system alarm. System alarm are generated from faults within the BPCS or SIS hardware or software. Right. So these can be useful, but care should be taken that they are relevant to the operator and easily understood by the operator. Okay. So that point also we need to take note. Then deviation alarm. So basically this deviation is generated if the difference between two analog signal exceeds a certain size, isn't it? So typically used to compare a controlled variable against the controller set point and no one, sorry, yeah, again the set point and to warn that the control system is failing to operate effectively. So here care should be taken that the alarm is not generated during large process disturbances where the control system is doing the best it can, but the control error is large. So to avoid this, we may need to incorporate time windows or time delay, isn't it? Yes. So the alarms may also need to take account of whether a control loop is selected to automatic or manual operation. All these we need to take note, friends. Okay, this is about the deviation. Then discrepancy alarm. Discrepancy, as you know, it is generated by comparing an expected process state against the actual process state. So maybe you take a case of actuator. Okay, so this requires some model of the expected movement of the actuator in response to the movement of the commands from the operator. See, for example, the actuator should always show the correct state, open or close, within 10 seconds of the command being sent. Okay, right. So a good discrepancy alarm check will identify faults such as stuck actuator or stuck actuator runaway, all these. So this is about the discrepancy alarm. Then we have one more rate of change of alarms. Rate of change of alarm is generated by the rate of change of analog signal exceeding a defined setting. So these often can provide an early indication of upset. However, it should be used with great care since noise on the signal tend to be amplified and can result in spurious alarms. So thus what we have to do, we have to incorporate time window or time delay. So these are the things I want to put forth as part of the types of alarms while we design the alarm system, friends. Okay. And of course, there are many alarms also. They're like adaptive alarms, adjustable alarms. That and all we are not focusing here in this session. Okay. Of course, if any of you are interested, you can just comment. I'll post a separate video. Then, first up alarm. As you know, first up alarm in a facility, or maybe first up alarm is a facility for examining the order of occurrence of alarms that may occur in quick succession, right? So this would be used to identify the cause of the process disturbances, right? Isn't it? So due to scan time, the order that alarms occur may not be true reflection of the cause and effect, right? Because fast scanning logic allows the first alarm after the trip to be identified and hence the cause of the problem to be determined. Okay. Hardware, you may be knowing, right? We have a sequence of event module actually. We can provide this to provide an accurate first alarm list. Okay. So that is the point as want to just put forth as part of the first alarm. Okay. First up alarm. Okay. So now I want to go into the selection of alarm settings. So as I mentioned earlier in the first slide, alarm setting should be properly defined during plan design, commissioning, and reviewed and optimized based on operational experience, isn't it? So how to do this? Friends, uh, alarm setting should be defined properly. Yeah, that's what I meant here. Okay. This is particularly important on absolute alarm. We talked about absolute alarm, right? Yes, that indicate approaches to process operating limits. All too often conservative alarm setting are chosen with the consequence that alarms occur during normal operational fluctuation. For example, take a case of this diagram actually. Alarms here, this is effective alarm, this is ineffective. Why this is ineffective? Why this is effective? You see here, friends, the alarm should be set, or probably here what we have done is the alarm is set on the boundary between the normal and upset state of the process. So you see here, this is your normal and this is upset. So it should be set on the boundary between the normal and upset state of the process. That is why it is effective. If you set all over here, so that is not going to help you. That is the point. Okay. So in the next slide, I want to talk something here. In a process perspective, I'll come to this later. So in a process perspective, in practice, the choice of alarm setting is complicated, and we should take into the following items. What are all the following? One is the process dynamics. Okay, process dynamics means the amplitude and duration of acceptable normal operational fluctuation. So we need to focus on the process dynamics. Second item, the limit at which automatic protection system will operate. What is the limit? And the third is the rate at which the alarmed variable may be changing during the upset. What is the rate? And the time it will take for the operator to diagnose and respond to the problem. And the time will take for the time will take for the process to respond to the action taken by the operator. So these are the scenarios we should take note while doing this alarm settings. Okay. Now I will want to explain with this. You see, friends, here basically, this shows how the set point of an alarm with an absolute set point should be defined, taking into account the time it takes for the operator to act. For example, you see here the alarm activates here, right? And the process start responding here, right? Uh, so, and after that, the undesired event is going to happen, right? This is the C. So here it activates, okay? Then the process response, okay? Then this is your undesired act. So the aim of this objective is to define a set point so that A plus B is less than C. That's it. Very simple. So this is what we need to focus actually. Okay. But sometimes conflict between the factors will mean that it will be impossible to set an alarm at a value where alarms will not occur during normal operational fluctuation. Yet, it will allow the operator time to correct the problem after the alarm occurs. So, in that case, what we have to do? We have to redesign the plant, its controls to provide a greater margin between the normal operating limit and occurrence of the undesired event. But this is the most desirable solution, but often it is not practical, isn't it? We can't, put a great margin between normal operating limits and occurrence, right? So that is not possible. So yeah, likewise, there are many things are there, but anyway, we will not dive deep into it. Okay. So another some important point I want to also put forth. Yeah, here, due to the operational importance of achieving effective setting, so generally it is recommended that alarm setting should be systematically determined and documented during plan design, commissioning, and operation. All changes should be documented with reason. Alarm setting should be reviewed against the actual operating condition. And that is the point, actual operating condition, and tuned to ensure that they satisfy the requirements. Okay. So these are all, the topics which I want to give you as part of this practical consideration for the alarm design. But there are many more, but going by the the response, it looks like I cannot continue this unless I have some special request. I will prefer to stop with this, and I'll choose some other topic, friends. Thank you. Take care. But really, I'm a bit disappointed with the response for this video. Anyway, this is all part and parcel of so let's continue with some other topic unless somebody, has, come out with a special request to continue the other videos, other sessions. Thank you. Take care. Bye bye.